Hello, sir. Hello, sir.
All right.
No, sir.
Okay. Hello. So to those who haven't eaten lunch yet, so again, you can eat while listening. All right. So let's continue now our discussion. So again, it only has three parts in total. So we have the solder mass, the copper, and then the substrate. Okay. So the solder mass here or the copper can be found on the top or the bottom. So if it's a double-sided PCB, then mostly it's on the top and bottom. But if it's a one-sided PCB only, mostly it's on the top side only. All right. Okay, so here are the parts of the PCB. So the first thing that you need to know is the FR4. So what is this FR4 stands for? So FR4 means, where is that one? Where is here? So FR means flame retardant. Okay. So this flame retardant or this word FR came from NEMA. Okay. So NEMA is the National Electrical Manufacturers Association. So we could say that this NEMA is the standard, or they've done uh, a checking or standard check with that fiber glass or fiber grade designation. Okay. Fiber glass reinforced epoxy laminate material, whatever it's that. But let's just say that it's fiberglass. Okay. So again, FR stands for flame retardant. Okay, and that's not denote that the material complies with the standard UL94B-0 unless testing is performed to UL94. Okay, so they have this kind of standard. So whatever it is, so the UL94V-0. So this one is the vertical flame testing. Okay, so this is one thing that you guys need to worry, okay, especially if you're going to create your own project. So make sure that it is a legitimate, okay, PCB, okay, because there are PCBs which easily burn, okay. Like for example, uh, I guess I wasn't able to include that one. Okay, so let's find that video. I just would like to show that if it's a super cheap PCB, it will easily burn. Let's see if I was able to add that one on the module overview. Syntax. I guess I wasn't able to add that one. Just different video, I guess. All right, since we are here already about flux, okay. So as you can see, this is just a simple copper wire. So he wanted to connect the red wire and then the black wire using a soldering iron and then a lead wire. So if you're going to take a look at this one, it doesn't want to stick on the copper. Okay, so that is where soldering flux comes in handy. Okay, so you can add this one. Okay, and then just melt it with the LED. Okay, LED wire, not LED. Sorry. Okay, so as you guys can see, it now holds the wire better than a while ago. Okay, so yeah, if you want to connect two wires, then this is where soldering flux comes in handy. So you might want to buy one just in case. Okay, so this is just a tip and tricks. And one more thing is, if it cannot stick with your hole, okay, then you can also use the soldering flux to stick. Wait, so the person's distracting me. Okay, so while I'm speaking. So in here, as you guys can see, the PCB is burned from the soldering iron. Okay, so if it's a original PCB or a high grade PCB, so you can easily remove that burn. Well, in fact, it didn't burn all through down to your PCB. Okay, so that is just a smudge wherein you can uh, apply some isopropyl alcohol and then just brush it, and then it will be gone. Okay, so that is one thing that you have to careful, especially if you're going to take a look on this one. You have a printed path in here, and if you burn that printed part, okay, then there's a chance that that printed uh, path or copper will not work properly. Okay, so especially if it's a super cheap PCB. Okay, so yeah, just another advice, just in case you're going to buy a PCB. Anyway, if it's for practice purposes, then you can buy the cheapest one. Especially, uh, let's say you have the breadboard and then you want to connect it manually without printing it, okay, just by drilling it manually. So yeah, that one might come in handy. But if it's a printed circuit board like this, then you should level up the quality of your PCB. Okay, because this is where you are going to solder a lot of components. Okay. All right. So enough with that. That's just one thing that I want to mention when it comes to PCB. All right. So what else? So yeah, that's for the FR4. And here are some cheaper PCBs and perf boards. So this one is uh, example of chipboards that is made from other materials such as epoxies or phenolics, which lack the durability of FR4. Okay, so I actually would like to say that if the color of the PCB is like this, then it's already made of epoxies and phenolics. But I don't have enough research. Okay, I don't have my enough information with me so that just ask the electronic owners if this is FR4 standard. Okay, so in here, it is saying that this one is the cheaper PCB, wherein it will easily burn the PCB itself, okay, upon soldering some components. Okay, we have already, and yeah, one more thing that you need to check is they said that if it has a bad smell, okay, upon soldering some of your components, then the PCB that you're using might be a cheaper or a cheap PCB, okay, which is not an FR4 PCB. Okay. So anyway, as time will go by, you'll be able to learn what is the best PCB for your project. Okay, so that is why I encourage you guys to buy your own PCB so you can uh, do a lot of simple projects. So just by lighting up a simple LED, okay, just by creating a simple speaker, just by having this kind of measuring circuitry, like it can measure sound waves, can measure water level, etc., etc. Okay, so you will know soon, okay, that the board that you're using is a good one or a bad one. All right, and here, so phenolics have a low thermal decomposition temperature, which causes them to delaminate, smoke, and char a little. Okay, so char means it will get burnt. Okay, so the one that we saw a while ago, the black one, so that is the definition of char. Okay, so hindi ito yung char na expression natin. Okay, so me myself have also searched what is the meaning of char. So I thought this one is short term for character, but it's not. So I would like you guys to search this one also. Char means like get burned or a blacky part on that, let's say, burnt part. All right. And we have here the solder mask. Okay, so the solder mask is the topmost layer. Okay, the green one. So it is the coating of our copper. Okay, so actually you can remove the solder mask. So we have uh, uh, liquid components for I forgot the name, but yeah, you can deoxidize this one and then just reveal the copper one. Okay, so the purpose of this solder mask is to protect the copper, okay, whatever is on the bottom of it. So it could be a copper, it could be aluminum, or it could be chrome. So sometimes we have different kinds of metal below the solder mask. So it's not only copper, but mostly it's copper, but it's not limited to copper. All right. So this layer gives the PCBs its green, or at spark fan, it's red. Okay. So this image right here is an image came from spark fan. Okay. So they put the color here red for the solder mask. Oops. Okay. So it is overlaid on to the copper layer to insulate the copper traces from accidental contact with other metal. Okay. That is one reason why we have the solder mask. Okay, because if other electric or conductive metals touch the copper, then it will short the entire circuit. Okay, so that is the purpose of the solder mask, to protect it from scratches or from getting uh, shorted with other components or other PCBs. Okay. So this layer helps the user to solder the correct places and prevent solder jumpers, right? And we have here the silk screen. So the white one that you're seeing is made by silk screen. So again, it doesn't do anything on our PCB. It's just that it is helping us to identify what is this component. Or in other words, silk screen is there for us to see the labels. Okay, so this is our guide, okay, for us to know what is this component, what is this path, where is this going? Is this a positive or the negative? Okay, so you'll be able to know the polarity of your PCB, right? So yeah, that's it for the intro to PCB. Okay, so just 16 slides, and then the following 17 up to the 87 is already for the Eagle CAD. So before we proceed to the next one, do you guys have a question so far?
Wala pa naman, sir.
Wala rin, sir.
How about the others? Any question, guys, or clarifications? All right. So in here, you won't be able to appreciate this one. Okay. So you will not be able to appreciate this one if you don't have the Eagle CAD software yet. So may I know who are the people who doesn't have an Eagle CAD software on their laptop or desktop yet? So you can chat or raise your hand. So there's one. Who's that? I think that's Mr. Light. So Miss Santiago, Mr. Godfrey, Mr. Barasi, Mr. Golaitan, Mr. Dumagat. Ang dami nyo naman. Okay. So, for now, okay. So, tiisin nyo na lang muna. So, just follow us. Okay. But anyway, this one is self-explanatory. Since I put here this step-by-step on how to create a simple project, on how to import, on how to add, how to route, etc., etc. All right. So, to those who have their Eagle CAD with their laptop or desktop. So I would like you guys to open your Eagle CAD now. And you will see this interface. So we call this one the control panel. All right. So are you guys here already? Nandito na ba kayo sa part na to? So once you're inside, okay, once you're inside at the control panel, so I'll only mention two. Okay, so the libraries and then the projects. So for the libraries, this is where you can import some of the libraries or components that we cannot find on the Eagle CAD by default. Okay, like in my case, I have imported a lot of libraries that came from SparkFun. Okay, so yeah, this is one way for you to add your libraries. Well, you can also do that one while you are inside of the project itself, while you're on the schematic. And then the next one is the projects. So of course, this is where you're going to create the folders for your project. So in my case, I have created two folders. So this is just for demos, sake of demo. So the first one is projects, and then the next one is new projects. Okay. Or you can just create, no. So I guess it's required. Okay. So it's necessary to put a folder. Okay. So just create a folder so you can name it any name that you want. Okay, and then it will lead you here. So once you're done creating a new folder, okay, then you can now right click on that folder and then click new project. Okay, so in my case, I have already created this one, my first project. Okay, let me just delete this one. Gawa tayo ng bago. All right, so I'll just create another one. So new project. And ano ba magandang pangalan? Project Eagle. So you can name it any name that you want, but in my case, I'll name it Project Eagle. Okay. So once you're done, then right click again that Project Eagle or whatever is the name of your project, and then click new or choose new and then choose schematic. And then this interface will pop out. All right. So in here, we are now on this part. I wasn't able to include the interface after clicking the schematic. Anyway, so once you're done with that, then you will see this schematic, okay, schematic layout. So in here, we call this interface or uh, window as your schematic layout. Okay, so the other layout is called the board layout, but we'll move on another one once we're done with our schematic layout. So for now, we have to add some parts. Okay, so how to add a part? So in here, schematic design is a two-step process. So of course, the first one is schematic sheet, and then the next one is where is that one? It's lost. Anyway, so we have the schematic layout or schematic sheet, and then the board layout or board sheet. Okay, so of course you have to wire or connect first the components that you have on the schematic layout, and then you can now import it to the board layout. So in here, you can actually intermix those steps. So let me just show to you guys what is the board layout. So for example, for now, I'll just add some random components. Oops, not that. Logic gate. All right. So for example, I have a lot of components already. So if you want to switch, okay, on the board layout, then just click this one. Okay, on the upper left, we have this STH and then BRD. Okay, and then it will ask you if you want to create a schematic if it's your first time to, have the board layout or the schematic layout. Then just click OK, and then it will lead you to this another interface. Okay, so this is another window called a board layout. All right. So in here, it will give you a blank canvas wherein, let's just say that this is your blank PCB. Okay. So in here, this is where you're going to put your components. So initially it's on the outside, and then you can now, put all of your components inside of this PCB. So mostly, if it can only cover this portion, you can resize this one, okay, into a smaller one. So why did I do this one? Because the smaller the PCB, the better. Okay, you don't want to have a very big PCB, but you only have 5 components in it. Okay, so you're wasting the size of your PCB already, or you're wasting your money. Okay, so again, the smaller, the better, right? So yeah, that's it for the board layout. So if you want to go back to the schematic layout, then you can click this SCH. Okay, and then it will lead you back in here. All right. So can you guys still follow? Hello?
Sir, how do I put that?
Can you guys still follow, guys?
How do I put that part there? Dun sa eagle. Yung red na yan.
Board layout.
Yeah.
Ano yan? Ito?
Yeah.
No,
Yes,
no.
sir.
This is just a random component. So you can add any component. Okay.
Yeah,
So this
sir.
is
How do
just
I
for
add?
the sake of demo. This one right here. So in my case, I don't usually use the tools in here, but mostly whatever is the name of that tool, okay, you can type it on this search bar in here. So just search add, then click enter, and then it will show, or this add component will pop up.
Okay, sige. Kita ko na, sir. Thanks.
All right. Okay. Well, the point here is you can intermix those steps. So you're not limited in, once you're done with the schematic layout. Okay, once you're done with the schematic layout, you cannot go back and edit your schematic layout once you're on the board layout. So you can do those at the same time. Like for example, you already have your board layout, but you still want to add another components. So add, say I want to add another. All right, so let's just say another one of this. And then let's say I want to connect this one. Okay, so in connecting components, use net. Okay, so do not get confused with this one. So we have line, and then we also have bus. But the one that we're going to use is net. Okay, not the bus, not the line. Okay, so it's always the net. So just click net or type here net. Okay, or if you want to use the shortcut, you can use Alt N. Okay, if you want to learn more about the shortcuts, you can go on the options and then assign. Okay, so in here, it will give you the shortcut key for the add, copy, delete, errors, ERC, run, window, etc., etc. Okay, so you can even add if you want a new. Okay, you can even add a new one, and then create your own shortcut. Okay, so in my case, I have only a modify one, okay, which is the window fit. So later on, I'll show on how to do the window fit because by default, it's not on our shortcuts. All right, so for now, let's wire things up. So there you go. Let's just say that this is also connected with each other. So whatever is your changes on the schematic layout will also change, or will also be updated rather, okay, on your board layout. So as you guys can see, we have another component here, and then they also have their own connections. All right. So as you are starting to add a component, you can already arrange them on the board layout. So to move it, so just click this move, or just type move, and then just look for this crosshair, okay, and then just left click that one, and then there you go. And then to zoom in and to zoom in and zoom out, so you can use your scroll, scroll of your mouse, scroll, how do you call that? A scroll bar. Okay, so you
Scroll
can use
wheels.
your scroll bar, scroll wheel. So that's why it sounds weird. Anyway, so let's say you're already moving this thing, and then of course you want to rotate this one. So just click your right click, okay, and then you can now rotate that certain component, okay. And if you want to mirror, okay, just click your middle, or click your scroll wheel, okay. So in that case, you'll be able to mirror it, and then you can still rotate it. All right. Anyway, so yeah, that's it for the schematic and board layout. Okay, so again, in adding a component, just look for this icon, okay? Or you can type it on the search bar, add, okay, and then hit enter, and then will give you this interface. Okay, so I will delete everything for now, okay? So what I did is I grouped them, okay? So to undo, can add the same, it's Control Z. So just group them and then hit the delete button, and then you'll be able to delete that group or that component. All right, so the first thing that we need to do is add a parts, okay? So let's say we want to add LM555, okay? So let's do that one. So add a part, and then type here LM555. And then click OK. And then as you guys can see right here, it didn't show anything, okay? So the search bar on the adding a component doesn't work like Google, okay? Like it will give you the related components or related things, or anything, okay? Anything that is related with this keyword, okay? So in adding a component on the EagleCAD, you should put the literal, the exact name of that component. So you should know what is the exact name of that component. So well, memorizing the components will be very, very difficult, since we have thousands or even millions of components. So in that case, we can use wildcards, okay? So wildcards can be done by question mark, okay? So just add a question mark at the end, and then hit enter, and then it will give you any similar or related components with LM555. So in here, it showed one, which is under linear, and then 555, okay? And this is the reason why LM555 doesn't show up, because it lacks the word, the letter D and N. So it has two types of LM555, okay? So if, let's say, the part or the component that you're looking for still not in here, then you can add another wildcard, okay, which is the asterisk. Okay, just add asterisk before the name of the component. So asterisk LM555 question mark, and then hit okay. Oops. No valid items been selected. Prints required. Okay, so if that didn't work, okay, so this is the last one, this which is the most recommendable. Okay, just add or just change that question mark into asterisk. So we have asterisk before and then asterisk after the name of that component. So just click OK. Why? What happened? Okay, let me just reset this one. So to reset it, just click this X right here. So it will clear the search text. Asterisk LM555 asterisk. All right, so for the keyword LM555, so it's still the same, but changing this one into asterisk will widen, okay, the variety of the keyword, okay, whatever is inside of that asterisk. So if you want to search for the 555, then it will give you many 555 components. So 555, 140, etc., etc. Okay, as long as it has a 555. So yeah, you can complete it at first and then lessen it, okay, just by removing the LM. If you're looking for a certain 555 component, then you can do that one. All right. So are we clear so far on how to search a certain component on the Eagle CAD?
Clear, sir.
All right. So one more thing that you guys need to know when it comes to searching some components, especially the resistors, capacitors, and inductors. So in here, we cannot actually, well, let's try RCL. So yeah, so the main category or the main name of the resistors, conductor, and capacitor is actually RCL. Okay, so RCL. So as you can see right here, I've used wildcard already, which is just looking for any name that has RCL, but it didn't show anything. So this is a different component. Okay, so I don't even know what is this component. So to look for the resistors, capacitors, and inductors, you have to look for it manually, right? So just X this one. Okay, just reset the search button, and then just look for the RCL manually. Okay, so right here. So it's RCL, and then just double click that one, and then it will give you this capacitor, inductor, and then resistor. Okay, and then inside of it, of course, there's more variations when it comes to CEU, CTRIM, CUS. Okay, so one thing that you can base, okay, if let's say you don't know what to choose, okay, this is a capacitor, this is also a capacitor, this is also a capacitor. All of them are actually capacitors. So we have a lot. So one thing that you can base with is the popularity. So in here, we have, upon clicking the specific component, it will give you the description. Okay, so it has a grid of 2.5 millimeter. It has an outline of 2.4 times 4.4 millimeter, etc., etc. Okay, so if you're looking for a certain components and then you're not sure which one to choose, then yeah, maybe you can read it first on the description part, or you can just simply base it on the polarity. I mean, popularity. Okay, so in that case, it will give you much more assurance that the component that you're using is compatible with the other components. Okay, well, in fact, any specific capacitor will do. Okay, so they are just simply a layout. Okay, it will not affect your or how your circuit works. Okay, it's just that it will give you this kind of layout. So it has 3 pins. This one has 2 pins. So one also has 2 pins, but different in dimensions. So this one is a little bit wider. This one is a little bit narrower, and also narrower, and then much more narrower. Okay, they just come with different sizes. Okay, so that is one thing that you can also base with, and base it from its size itself. So this one has a 5mm or 0.2 inch in size. All right. So yeah, that's how you add a capacitor, inductor, or resistor. All right. And yeah, all right. So once you're done with those thing, then the first thing that you need to do is add a frame. So in any project, you should always add a frame. So yeah, frame is not that critical component. Oops, sorry. Okay, so we don't have enough time anymore. So we'll just continue the rest on next meeting. All right. So I guess we now only have 10 seconds. So goodbye for now and see you guys on part 3.
Bye, sir.
Goodbye.